Alright, so let's take a look at this this next one. An empty volumetric flask weighs 74.85 grams. After 25.0 mils of a liquid is added, the flask and liquid weigh 11.50 grams. What is the density of a liquid? Alright, so when we're doing this kind of problem, what we've got here is we need a density, which is going to be the mass divided by the volume. We actually already have the volume, which is 25.0 milliliters. But the mass here is going to be 111.50 grams for the total, and then the flask itself weighs 74.85 grams. So we need the mass of the object, and the mass of the object will be 111.50 grams, minus 74.85 grams. And that's going to be 36.65 grams. Now, looking at the significant figures, we're doing a subtraction here, so we're going to deal with decimal places. So this is 2 decimal places, 2 decimal places. So our answer comes out to 2 decimal places as well. And notice that we're not using smallest number of significant figures here. So now when we go ahead and get the density, it's going to be the mass divided by the volume, and the mass is going to be our 36.65 grams, and the volume here is 25.0 milliliters. Now I want you to note here that it's important to get the correct number of significant figures at this point because we're mixing operations. We're going to do an addition subtraction first, and then we will do a division, and that means we're going to have to make sure our significant figures are correct at this last part, which they are. And that's going to give us our final answer as being 1.47 grams per mil. Looking at number of significant figures here, you've got 4 sig figs in this one and then 3 sig figs here, which means our answer is going to come out to be 3 sig figs as well. Alright, so looking at the next one, we've got a graph here, and the graph is a graph of mass against volume, or volume on the x-axis, mass on the y-axis. And the first question it's asking us to do is to figure out what the y-intercept is. The y-intercept of this graph is going to be 50, and 50 grams is going to be our answer there. Now it says to take it to 3 significant figures, but you know, for a graph it's kind of hard to tell what number of significant figures you need to use, especially if you can't tell how many graduations there are. That's why arbitrarily you've been told just to go ahead and take it to 3 significant figures. Now since the y-axis is in grams, and that's where the line cuts the y-axis, so it's wherever x equals 0, that's the y-intercept, and that's going to be 50 grams, 50.0 grams. On a practical basis, the reason we're showing you this is that you can actually find the density of a liquid by measuring its mass at different volumes. So at 0, when the volume is 0, the mass is 50 grams. That would be the mass of the empty container. Then we go ahead and add 100 milliliters, and the mass goes up to 200 grams. But that would be the container and the liquid. But the density of the liquid then can be gotten by finding the slope of the line, and that's what we're going to do here. The slope of the line is going to be measured from our slope equation, which is y2 minus y1 over x2 minus x1. And if we're finding the slope between a and b, we've got a, which is 0, 50, and b, which is 100, 200. So we can see that it's going to be, if we're just doing the b minus a, it'll be 200 for the y, it'll be 50 for the other y, and for the x values it's going to be 100 minus 0, and that's going to come out to be 1.50 grams per mil. So you can see that we've got grams on top here, and we'll have mils on the bottom here, and that's because we've got grams on the y-axis and we've got milliliters on the x-axis. So that's how we end up with our density, 1.50 grams per mil. We're also asked to find the slope between b and c. We're going to use the same equation, and you can see that C, the Y value is going to be 350. The other Y value is going to be 200. That's for B. For the X values, we've got 200 and we've got 100. And that's going to give us the same value, 1.50 grams per mil. Now it's a straight line, so we expect the slope to be the same between each of those points. So this would give a constant value of 1.50 grams per mil, and that would just be the density of the liquid right there.